This is an HP 3586C Selective level meter. These were originally used to measure levels on multiplex telephone lines. It'll measure from minus 100 dBm to plus 20 dBm over a frequency range of 20 Hz to 32.5 megahertz over a BNC connector on the input here. It'll measure from 100 Hz to 108 kilohertz over a balanced 600 ohm inputs. Also has a tracking generator that has an output on the back that follows the input frequency. It can connect into a input on the output here. It's labeled 0 to 32 megahertz on here. There's also on the back here you can connect an external 10 megahertz source. Some of these also have a ovenized oscillator as a reference. I'm not sure if this one does or not. Should list the options on here someplace. Well, anyway, this one is tagged as malfunction, so obviously it doesn't work. Okay, I'm going to power it up and see what we get. The standby light came on and hit the power switch. Of course, it's got the customary jet engine fan in it. Well, it seems to be locked up with the, looks like either an R or a right angle in all of the outputs here on the indicators. Here's a look inside. Typical Hewlett Packard goodness. It's like power supply back here. Now this one's got the ovenized oscillator option in it, which is good. Okay, we got some LED indicators. Here's one here. On this, all these modules plug in to connectors. This one's got a step unlocked LED indication. And here's an LED here. This board's got some indicators in green. Not sure what any of this means. I'll have to look in the manuals. Power transformer back here. Yeah, none of the buttons have any effect on the input. And I don't see any switches as far as an external reference, etc. You must automatically switch if you connect a reference. I don't see any kind of a switch. It's got a GPIB bus in it. Well, this one's going to take some work. I think what I'm going to do initially is I'm going to pull these modules out and reseat them on the connectors on the board. Uses a standard connectors here, if you can see, and down in there, regular edge connectors on it. I do have service manuals here. I've got volume 1 and volume 2, which hopefully will have the information I need to fix it. And I have the operator manual here, so a lot of information here. It's a complicated instrument. So next step, I'll reseat the boards and then we'll power it up again and see what we get. Hopefully not this. When I first turned the unit on, the display showed all R's on the LED readouts here. In looking in the manual under turn on calibration failures, it says if both display areas immediately fill with the letter R, the turn on write read test for RAM memory has failed. The problem is on the A60 board. This is the A60 board, this one right here. So what I did, I have two other units here. This one was obviously robbed of parts. The connectors are gone between the boards. This unit is more complete here. And I was able to pull out the A60 board out of this one, which is this, and install in this unit. And that cured the problem. This is a controller. There's a view of it here. Oh, they don't make them like this anymore, do they? All gold-plated boards. One of these things cost, I think it was like $11,000 when they were new. Okay, I plugged the unit in. You can see a standby is on. And since this unit has the option 004 precision time base, the quartz oscillator heater will come on and heat up the time base to stabilize it. So when I hit the power, it will go through a calibration sequence, which takes a few seconds. And I got an error 8. Okay, I initially turned the unit on and got an error 8, and according to the manual, the frequency reference loop is unlocked. It says verify that the problem is not caused by an invalid external frequency reference. Test features that you can enable that will test the functioning of the unit here, and you do that by typing in codes into the unit. For example, if I hit recall dot center frequency 8, this is going into a testing sequence that's testing the unit, and if they pass, they'll tell what they're testing and if it's passed or failed. When group 5 comes on, this is kind of interesting according to the manual. It plays Beethoven Symphony number 9. Sounds like an old video game from the 80s. Okay, now it's going into a calibration sequence here. This happens every so many minutes, or if you change the frequency more than, I think it's 1 megahertz. It takes a while to go through this manual. It's each manual is over 2 inches thick here. Turn the volume down. You can enter the frequency by hitting frequency in megahertz. We'll measure your frequency out here. Here's a description and a little history of these instruments. I'm not sure when this one was built. The manual I have is a date of 1981. These were originally used to measure levels on multiplex telephone lines, the frequency division multiplex that was used on those lines, and it'll measure from minus 100 dBm to plus 20 dBm. And the frequency range of the unit is 200 Hz to 32.5 megahertz. And on this particular unit, the 3586C, the input comes in here on a BNC connector on the front. It also has balanced inputs for audio frequencies that are 600 ohm down here on these three banana jacks here. This unit has a tracking generator in the back that follows the frequency that the unit is set to on the front panel here. And it outputs a 0 dBm signal, which is 270 millivolts RMS. This particular unit will detect both upper and lower sidebands. Here you can see the symbol for lower sideband and upper sideband. It has three filters that are variable: 20 Hz, 400 Hz, and 3.1 kilohertz. It'll measure power in three different units, reference to dBm, which is 1 milliwatt, or dB voltage, dBV of 1 volt, or a dB of 0.775 volts. The meter has two ranges here, 10 dB and 100 dB. The input here can be terminated in either 50 ohms or 75 ohms here, this connector, or if it's unterminated here, it's a 10 kilohertz input into 50 picofarads. Here's a functional test of the digital circuits. And to get into that routine, you type in recall dot center frequency 9. And according to the manual, this is the date of the latest version of ROM in the software, so June of 1980. So a little bit age there, but it seems to be working all right. It's passed the test anyway. Okay, I went through a calibration since I changed the frequency more than 1 megahertz. I've tuned to WWV at 10 megahertz. You can hear if I zero beat it, to measure the frequency, I hit counter, and this will measure the frequency. Now you can see there's an error here. I'm off 10 megahertz by a little bit. What about, well, it's kind of bouncing around here. I hit average. Pretty close. The stabilized oscillator hasn't been on that long, so this will probably change. And I don't know how long ago this was calibrated. I can compare it to my rubidium standard or my GPS standard, but it's close to 10 megahertz. You can change the frequency by the tuning dial here, and it's got the three bandwidth filters here: 20 Hertz, 400 Hertz, 3.1 kilohertz. And you can change the rate of tuning also, the frequency step. For instance, if I want to change it by 1 megahertz, let's set it at 10 megahertz. There's 20 hertz, 40, 60, 80, 100. I guess you get the message there. You can turn it off with this, put it on auto, you can tune it. I've tuned the receiver of the unit here to a local AM radio station, 1310 kilohertz. And you can hear now when I hit counter, it will measure the frequency of the station. It looks like it's off, what, 500 cycles about? Which is, this unit's off because the time base is not warmed up yet. But we'll see later as that warms up how accurate this is. You don't have to tune it exactly on the frequency. The unit will automatically, right now I've got it tuned at 1.3097. Now when I hit the counter, the receiver will automatically lock on and tell me what that frequency is. And go to a 400 hertz filter. Come on the 20 hertz filter now. So then at 2 cycles, 3 cycles. Look on the left here, there's an analog meter and an actual digital meter here. You can see how as I tune into the signal the level changes. I'll come up onto the signal. It goes into a calibration. It does this every so many minutes, or if you change the frequency more than 1 megahertz. I'm terminated on 75 ohms because I'm actually using RG6 75 ohm cable. I've got a long wire antenna outside. It's not very long, but it's long enough for this. You know what that is? One of my last videos, the battery charger with the pulse mode on it. That battery charger is in another room. I'm going to go unplug it. That's that beautiful that beautiful AM transmitter battery charger. We have the unit tuned into the 20 meter amateur band, single sideband, lower sideband, upper sideband. This speaker's pretty bad here. I need to connect an external speaker, an amplifier here. Sounds like a pile-up. Well, about 100 microvolts. That's minus 100 dBm, I should say. That's about 2.24 microvolts, according to the charts. That one signal's a little stronger. I've connected the F-sub-out connector in the back, which is the tracking generator that follows the frequency tuned in on the front here, and I've connected to a scope and a frequency counter. So here you can see the actual signal in the output of the back, and here's the frequency here. And as I vary, right now I'm tuned to WWV. I got the volume down. Okay, I'm going to tune it off a little here. I'm going to tune it down to 9.998. Here you can see. So you could use this signal. See, 2, 4, 6, 8. It's almost a volt. You could use this signal to drive a transmitter, use it as a VFO. There it went into calibrate, and you saw it go to calibration. So that makes this thing pretty versatile. But you can measure your parameters here, your power of your signal coming in. I'm going to, I think I'll hook a signal generator up next, which won't have quite the noise I'm getting here coming in from this wire. I have a signal generator hooked up to the input of the 3586C on band B, and I'm going to tune it through 10 megahertz. There's almost 0 beat. You can see it's drifting around a little bit. Frequency counter shows 9.98. 9.998. And there's the output on the scope. I just turned this on, so it's going to drift around a little bit. I've got a attenuator on the Clegg here. And looking at the output here, well, it's calibrating. I'll wait a second. Minus 73 dBm, 69, minus 69. Okay, I'm going to switch 20 dB. And I've got it on average. This will take a second. 93. Well, that's a little more. 93.45. Let's take it out of the average here, see if that's any different. 93, 94, 72, 73. Yeah, it's kind of bouncing around. 73, 75. Hit average again. 72. 94, 92. That's almost 20 dB. So it seems to be kind of working. I'm going to have to try to do a little better comparison here. I'll use a spectrum analyzer. But the unit seems to be working good, at least for one that came out of a pilot at Hamfest. Before I end this, I got a slight correction here. Earlier, when I was videoing this, I mentioned the termination here on this BNC. It's 10 kilo ohm, not 10 kilohertz, 50 picofarad. So that's a slight correction. And also, I didn't mention this, but it's important. If you have the 004 option, you need to connect a jumper between the 10 megahertz oven output here and the input external reference here. Just use a jumper cable to feed the quartz reference, the ovenized oscillator, into the unit. So those are two corrections I wanted to get straight here before I end it. This is kind of an interesting detail on the plug-in modules here. They've got lines drawn that converge from this point out, and it helps you put the modules in the right order. You can just connect the lines there, which is kind of neat. And all of the connectors for these coax cables, they give you the beginning and ending termination point, so it's easy to reconnect them if you have to reconnect the cables. Like I say, I got 3 of these at a Hamfest. This one someone was into and parts were removed. This one, neither one of these two had the 004 time base option, which is the crystal oven oscillator, which goes back here. If you can get one of these, try to get more than one. These were pretty cheap. I think these were 10 or 15 bucks a piece. Far cry from the original. I think it was 11,000 these things cost new back in the day. But try to get more than one if you can, because I don't think I would have got this one running without the spares here that I got. Try to get the manuals if you can. I was lucky at a Hamfest recently. I was able to get volume 1 and 2 of the service manuals, and they're quite involved. This is a big project. I'm going to have to go through this even more, but this video is going to get pretty long, so I'm going to end it soon here. But if you can't find the manuals, they are available on the internet as PDF files. So get lots of printer paper if you do that. I did print the operating manual from a PDF I got on the internet here. Anyway, this is a worthwhile addition to your RF lab if you can find one. Anyway, I hope you enjoyed it. Hope this was helpful. And we'll see you in the next one. Thank you for watching. Bye for now.